Welcome to Brain Vision.
So in this question, first of all, we're given a hazard rate, lambda of t equals a plus bt. And we're asked to find, first of all, the survival function. And this is related to the hazard rate by s of t equals the exponential of minus the integral of lambda of t dt. And we have to integrate that from 0 to t. So this is going to be the exponential of minus the integral from 0 to t of a plus bt dashed dt dashed. So this is e to the minus at minus bt squared over 2. That's our survival function. And the probability density function, f of t, is minus d by dt of s of t. So this is going to be minus d by dt of what we've got up here. So we've got minus a minus bt e to the minus at minus b over 2t squared. So this is a plus bt e to the minus a t minus b over 2t squared. That's our probability density function. And so the mode of the distribution is going to be the maximum of it's going to be the maximizer of f of t. So it's the maximizer of f of t. So now if we want to work out what that is, so let's get df by dt equals 0. And this is going to be b minus a. So we're going to get a minus a plus bt from up here. So we get minus a plus bt squared, but then we also need to take the derivative of this bit, which is just b. E to the minus at minus b over 2t squared. That's going to be equal to 0. So we get b equals a plus bt squared. So a plus bt is equal to root b. So t is going to be root b minus a over b. And that means, so that's the maximizer. That's the maximizer then of this function. So that's the mode. Okay. So now let's say that we have a survival distribution where s of x is ax squared plus b. For naught less than or equal to less than or equal to k. So the expected value of x is 60. But the expected value of x is related to the survival function by this is the integral from naught to infinity of s of t dt. So the integral from naught to k, s of x dx. So we get 60 equals the integral from naught to k of ax squared plus b dx. So 60 is equal to, so let's integrate this. We get a over 3 times k cubed plus bk. So that's one equation. But now we also need to do a little bit more work. So the probability density function is minus ds by dx. So this is going to be minus 2ax. And the integral of the probability density function from 0 to k of f of x is going to be 1, because it's a probability density function. So the integral from 0 to k of minus 2ax equals 1 dx. So 1 equals minus ak. So we've related a and k now. Sorry, ak squared. So we get that k squared equals minus 1 over a. Or, well, better, we should say that a is going to be minus 1 over k squared. So now we can put that back into this equation up here. So we get, so this is equation 2. So we get lambda of, we can use equation 2 to rewrite things. So we get s of x equals minus x squared over k squared plus b. And equation 1 has become 60 equals minus k over 3 plus bk. So these are our two equations now. But remember that our probability density function, so s of 0 has got to be equal to 1 because it's a survival distribution. So at the beginning, everything has to still be there. So that means that b is equal to 1. So we get s of x equals 1 minus x squared over k squared. And equation 1, which is talking about the expected value of x being 60, becomes 60 equals 2/3 of k. So now we can write down that k is equal to 3 times 60 over 2. So that's 90. So k is 90. And finally, we can write that the survival distribution is defined by 1 minus x squared over k squared. So x squared over 90 squared. And f of x is minus ds by dx. So this is x over 90 squared divided 90 squared times, divided by 2, 4050, and we have 0 less than or equal to x less than or equal to k. So now we need to find the median, and the median, m, is defined by the probability of x being less than or equal to m is equal to the probability of x being greater than or equal to m is equal to 1/2. So the integral of f of x from 0 to m dx is 1/2. So we get 1/2 is the integral from 0 to m of x over 4050 dx. So when we integrate this, we get 1/2 x squared. So we get 1 equals m squared over 4050. So the median m is going to be the square root of 4050, which is 45 root 2, which in decimals is approximately 63.6.